Hi everyone. Welcome to our next episode of TrueML Talks. And today we have co-founder and CTO at Fixie, a new generation startup in the generative AI world. Who Justin comes from a very technical background, having worked at Google. And of course, Justin will share more details on his career as well. So I'm super excited to have this conversation with Justin. And again, I'm Nikunj, co-founder and CEO at True Foundry. So welcome you all to this episode. Justin, if you can briefly introduce yourself, I would love to learn about your career.
Thank you, Nikunj. I've done a number of things in my career. I entered the industry in 1995, and one of the first things I worked on was AOL Instant Messenger when it was sort of first getting started. And I really, really got excited about the opportunity to have like this real-time interaction with people. And then over the course of my career, I spent a lot of time focused on real-time voice and video, of the ability to kind of have an experience like we're having right now. I thought was like really magical the first time I ever saw it, and like I really enjoyed working on that technology. You know, building out what became the first version of Google Meet, then building out WebRTC, and sort of understanding all the challenges that come into like what does it mean to kind of move audio and video across the internet in real time. And it was really gratifying to see that, you know, when the pandemic came, you know, this technology that we've been building and really enjoy using within Google, you know, everybody, you know, sort of became, you know, used it just to kind of get by and make sure that, you know, the world could continue as usual. And so, you know, now I've was very, very captivated by AI for a number of reasons. And now kind of trying to figure out like what's the path to integrate AI and RTC? How do we like, you know, interact with AIs in a real time capacity?
Got it. So is that kind of what led you earlier, from Google to Clubhouse as well? Would love to hear, kind of what got you into AI, and what kind of triggered your excitement, and how did you follow through that excitement? I guess. Yeah.
Yeah, it's an interesting story. You know, I'll start with like, you know, the first part of it, which is sort of that, you know, we built out WebRTC over the course of like, you know, the 2010s, and a really, really amazing ride. You know, working with the WebRTC team at Google, like an incredible sort of experience of building that out, seeing the technology come to life, working with other people within the standards bodies and other companies to make this whole sort of WebRTC effort across the industry come to life. And you know, one thing that we kind of realized though is that it was like we massively underestimated the scope at the start. It was an enormous undertaking to, you know, close to 10 years. But eventually it came to the point where a lot of the hard problems had been solved, and I was like trying to think about like what would the next sort of, you know, thing be? Where does this technology go next? You know, and you know, Stadia was one direction. You know, I worked on Google Stadia, and you know, one of the key things I did there was bring you know, Stadia to iOS on the web. And you know, it was kind of like a video call, but one side of the video call was like a machine that's running a video game. And so it's a really intriguing, you know, application of the technology of, okay, you can use RTC for things that are not just person-to-person calls. You can, you know, use that for, you know, interactions with what would be like services. And you know, then Clubhouse was another sort of thing of like, oh, maybe this is an interesting way of, you know, sort of taking the artist technology and finding like another sort of interesting way of applying it. But you know, one of the things that kind of, you know, started me thinking was I had been interested in AI, you know, ever since when I was a kid. I'd read a book about like what does it mean to be like sentient? What does it mean to understand? And one of the sort of anecdotes that, you know, I you know, came across, you know, was this essay by John Searle about, you know, the what they call it, the Chinese room, and it sort of talks about this notion of it really that, you know, could like a computer actually have understanding if all it's doing is following a set of rules. I won't get into all the details of the Chinese room thought experiment, but it's a really interesting thing to think about. And you know, it always like captivated me. It's like, you know, could like a computer really think like a person? Could any of this happen? And so flash forward to 2022. I'd been at Clubhouse for a while, but I was kind of, you know, contemplating like what other things were out there. And I had a chance to talk to Mustafa Suleiman and Karen Simonian in Reflection.ai. They were just kind of getting started, and they showed me some demos, and I was immediately blown away by like what they showed me. And I talked to some other people in the industry. I talked to Ashish Vaswani, who was at that point in time sort of starting up Adept. And again, I get to see some things, and I just couldn't believe what I was seeing. And
Right.
it kind of reminded me, like the first time I ever saw like video conferencing, or the first time I saw AOL Instant Messenger, that I really was seeing what was very clear to me was a transformative technology. And so, like at that point in time, I was like, oh, it's very clear what I'm going to do next. Like, I'm not an expert in this space, but this is definitely where the future is. And so, then I think the other part of the equation that filled in of like, what is the next direction for RTC? Oh, it was very obvious then. It's like the next direction for RTC is that these models which were just doing text will soon become capable of more than just text, and like RTC will be the conduit by which these things kind of communicate with humans, and we will find ourselves interacting with these models in all these new and interesting ways. And so that was a bit of a journey there, but that's kind of how all like the dots connected, and kind of how like I really got myself focused and excited on this new journey into the AI world.
That Yeah, that's such a fascinating story. And one of the things that I was noticing while you were talking, Justin, is once you have worked deep into any technology, it's amazing how you start thinking a lot of problems through that lens in some way, right? Like the way you describe like gaming as a video conversation with the it was very interesting. And of course, in the new world, talking to Mustafa, talking to the team at Adapt, of course they're doing like some such a cutting edge things, that it is indeed fascinating. And this world of agents and stuff that you're also working on right now, I would love to dive deep into that. But there is one more thing that I would love to talk about your early career before we talk more about Fixie, which is, so you come primarily from more of a sciences background, right? Like pure sciences background. So talk with us about that transition. How was getting into engineering, or was that like the most natural choice for you back then?
Yeah, I mean, it was interesting because my dad brought home my first computer when I was like 6 years old, and like I was very immediately captivated by this. Like, wow, there's like this thing you can give instructions to, and it'll do what you ask it to do, and you can like make a game, or you can like make something cool appear on the screen. But like in many ways, it's very much a hobby. That like, okay, this is for like fun, but if you are very serious about science and math, which I was throughout school, the path is to kind of go to academia and like become a professor. And so I graduated with a math and physics degree, and was then going to the Quran Institute for a PhD program in New York. And I like the computer science, whatever, always was like, okay, well, that's like a hobby thing. There's a job. Like that's not like the type of thing that like it's not the path that I'm on. I'm going to go be a professor. But right as like I was in my PhD program, like the sort of internet revolution sort of hit. That all of a sudden there was like it seemed like it was very much like the early days of the AI revolution of like, oh, Netscape was out, and oh, there's this thing called JavaScript, and oh, now there's Java and Java applets, and like suddenly like all these new technologies coming to HTML. And again, it was like a very transformative time. And when suddenly I was thinking about, okay, what does a PhD program look like? How many years will I be here? And yet there's like all this action going out here in computing, and like it basically clicked that like, oh, you can make a pretty good career out of tech, and it's actually extremely exciting as well. Um, and so like long story short, it was like I left my PhD program, and then sort of jumped on this sort of the bandwagon of the internet revolution. And so like that was like the sort of platform shift that gave rise to the beginning of my career. And I was largely self-taught, in terms of like writing code and like software development. So I never really had some of the skills like, oh, what is like DFS versus BFS and all these sorts of things that people who came out of like college who went through an
Yeah.
engineering CS program. but I felt like I had some different ways of thinking about things, that kind of was how I learned things, and maybe my set of tools was a little different than other people, and so I might be weak in some areas. I had some new perspectives that I could bring to problems that I thought was actually ended up being an interesting advantage.
Absolutely. Like I strongly believe that magic happens when disciplines meet. Uh, cool. Like now switch gears towards talking a bit about Fixie. Like tell us this introduce to us the concept of AI town and the characters in there basically.
Right. So, we sort of thought about like what would it mean to kind of have a social network, for AIs. And so like, communication is sort of like a human sort of need. It's like people love, just talking, just hearing good stories, like just like, asking interesting questions. And so we're like, how can we replicate this sort of a thing within like, the social network behavior where AIs are kind of doing a lot of the work. And can you have like an interesting conversation? Can you have like interesting sort of social media posts? Can you have these sort of interactions that are really meaningful and valuable? With AIs. And so uh, one thing was like, well, we believe in this vision of sort of multimodal AI and the ability to the value of human conversation and voice. But AI Town in many ways was a proving ground of saying like, if we believe in this, this will be the way where you'll know if you actually are onto something or not. Is that if you can have a call with an AI and you really feel like, oh, that was actually a pretty interesting chat, that would sort of say that okay, we figured it out. We know how to do this sort of thing. So AI Town is a place where you can talk to this AIs to various neighborhoods. AI Town was sort of give you and spin off of our first experiment in this direction, which was called HiSanta.ai. And this is what we launched for Christmas over 2023, where you could come and have a voice call with Santa Claus, as well as like some of Santa's helpers, including like, like the very, very popular Bad Santa. And, we got enormous traffic. Santa was powered by AI as well. And we were really surprised, by, how, much engagement that we got and the very wholesome and kind of, sort of vibe that, was created around this. And, people seem to really, really, really enjoy it. And so, Hi Santa, or sorry, Santa Claus and Bad Santa have joined us over in AI Town in the North Pole neighborhood. But there's lots of other neighborhoods with other types of characters, and there's Sue, the sous chef, who can help you make recipes and figure out, how to, make interesting meals. And there's a number of other interesting characters that we've all kind of created to try to like figure out like what are ways that we can make these characters helpful and entertaining and that sort of thing. And users can create their own. You kind of can give your character a bit of an identity, a backstory, a persona, and then they'll sort of stay in character, and you'll interact with them as such. And so, we can look forward to as AI Town grows, a number of interesting characters kind of like coming out of this, and we'll try to figure out what are the niches where these sorts of characters can really give an interesting experience. Can AI be funny? Can AI be kind of like witty? Going to be zany. These are all things that we're trying to explore as we go down this path.
It's amazing. Tell us about like how this AI town and like the characters in there like fit into like a bigger picture. Like I guess tied this back to like how you started when you started, right? Like what is it that the problem that you wanted to solve, and how are you getting along on that journey basically through some of these experiments and like findings that you're getting through these characters and stuff. Yeah.
I mean, there's so much that can be said here. I mean, I think I said there's two key things. One is like we spend a lot of time in the area of AI agents. An AI agent is a very, very overloaded term,
Yeah.
but conventionally, sort of interpretative meaning like some sort of AI personality or whatever that can kind of do things, a lot of times take actions, maybe act as your proxy or whatever. And along the way, we spend a lot of time, investing in like agents that could then take actions and call APIs and that kind of stuff. Uh, but we found that like the technology really struggles in a lot of these cases. That obviously, like I think this will be a very interesting in a powerful direction. But for an AI to do something and do so reliably, the technology just really isn't there yet. For it to go and like let alone like do financial things on your behalf, even just trying to give you answers. Like we all know about sort of LLMs and their stochastic processes. I mean, like there's worries about hallucinations. There's worries about is the training data accurate? But one of the things that AIs do extremely well, just out of the box, is conversation. That
Mm-hmm.
like they generate very very natural and a lot of times just effusive and compelling dialogue, because that's what they are. They're language models. They really understand the nuances of human communication very very deeply. And so
Mm-hmm.
that was our first thing of like, okay, find a task that LLMs are really good at already, and that we don't need some magical innovation or advancement of technology in order to deliver value. And so that was one thing. And the second thing was, to our sort of belief in like real time, that like, in many ways, ChatGPT, it's an incredible technology, but it's in some ways stuck in the command line era, that you have to kind of know what to type, and you type out this last thing, and that types something back at you, and like, yeah, it's great, it can write code, but I haven't really seen it kind of in many ways like cross the chasm. Like I talk to other people who don't like spend their days in front of a computer, and like they're like not sure, like they're number one question I get is like, what should I ask it? And so there's something about ChatGPT that just doesn't click for a lot of folks. And so our belief was that people invariably, when they want to communicate, especially having like an in-depth or kind of very like engaging conversation, the modality they choose is voice. I mean, that's what we're doing right now. That's what people do for important meetings. That's how they choose to meet with their friends and family. Text is convenient, but really, humans, they communicate best, when they have their use of the full faculties, which, is voice and video. And so we thought, what would it take, to get, these, amazing language models able to kind of communicate, using voice and video. And so, that was our bet in this direction of, we're going to lean into the LLM's ability to communicate, and then we'll try to figure out, how do we make them communicate in this really, really engaging way using multimodal. And so that sort of set the stage then for AI Town. It's like, this will be our experimental platform, where, it'll be, people can come and use it. It's a consumer platform. And we can learn very, very quickly, through like the consumer, engagement, are we doing it right? Are people enjoying the experiences that they're having? Are these characters fun? Are they novel? Are they interesting to talk to? And well, we could have certainly done that with in the B2B space too, but you need to find the right partner. You need to find someone who shares your vision. Uh, it's just like it's a little bit slower than going on like the sort of B2C path, but the consumer path that we're on right now, and it's great. Just like we push new features out there, we see people use them, we see what's working, we see what's not working, and we're trying to sort of figure it all out.
Got it. So it's basically becoming like a good playground to run a lot of experiments on, basically, in some way. Yeah.
Exactly.
Nice. And like the heavy big topic, like of AGI. Do you feel like this is like the direction in which we as an industry is evolving, like AI, LLMs, generative AI field is leading us towards AGI, or like you like what camp are you on, basically? Yeah.
Uh, so the overall camp that I'm on is that like we are on like a path where we will sort of you can see that we're kind of moving upwards in the stack of being able to have like these very natural sounding conversations, and some initial sparks of what you would call a thought, maybe, but it's still like a pretty long way from having like an LLM that could really pass for human, and get confused. They get confused with very very basic things of They forget, you tell us something and you ask it again, like, 3 messages later, and it's forgotten it. Um, and so it's pretty clear that, it's going to be a journey. And like, sort of talking to people who I respect in the space, like the overall thing I'm told is that it's going to be like a 10-year journey. And so like, yes, but the notion that there's gonna be some boom moment, and suddenly we'll have like self-replicating AI and everything. Um, first of all, I just think there's still some interesting problems to be solved. We'll see where GPT-5 gets us. And I think there's also just going to be a constraint on GPUs that,
Hmm.
I think most likely that, AGI level model is going to require an enormous amount of compute. And, for such a model to be accessible to like lots of people, I just don't think there's enough GPUs on Earth. And
Right.
you see Microsoft building out, just enormous data centers.
Right.
You see, just large amounts of investment in the space, because I think that the people who they know that this is what's needed. They know that the future models are going to be bigger and bigger and bigger, and that to even get to any of these things, we're just going to need, for the number of users, times the model capacity, it's just going to be an insane number of GPUs needed. And so ultimately, I think that our path to AGI is largely capped by like the physics of just like a number of GPUs, and then B, like what are like the power implications, of like, when I say power, I mean literally, how much energy does it cost to like run, if you have billions of users, the number of GPUs that's required to get for this to happen. So like, people talk about, what is the scenario by which we get to AGI? I think it's most likely possible, but I think it's going to be a slow takeoff, sort of scenario, because I think we're ultimately going to be bound by just compute and a number, I think, of important breakthroughs on the model side.
Got it. So the way I'm hearing this, Justin, is like, you're on the camp of when and not if, because like the major problems that you highlighted like seem like will get solved, like, given enough time, basically, given a decent amount of time, it seems like.
I think that's true. I think that's right. Yeah, I think that there's no reason to believe that they're going to hit something where it's like, oh, humans have this capability, and yet, that can't be reproduced in silicon. But I do think that it's going to be an awful lot of silicon.
Makes sense. Got it. Um, with all those fascinating topics, like, maybe like, I want to switch gears and talk a little bit about some of the more practical, like, tech stack type of stuff, and like, how you all are building Fixie. So like, maybe like the first very basic question that I want to start with, like, knowing a little bit more about is, how are you thinking about, like, the choice of LLMs? Like, what are you seeing is working? What type of LLMs have you all experimented with, and like, what are the learnings from there, basically, like open source, closed source, different sizes, latency? Talk us a little bit about that. Yeah.
Yeah. There's so many factors to consider here. I think, the two things maybe I'll talk about in depth will be, speed, because we're a real-time service,
Hmm.
and therefore, like, we need to really think about speed in terms of what it means for, a very quick and human-like response. I talk, briefly about sort of model power, that like, you want to have an intriguing conversation. That means the model needs to kind of remember facts, and be able to sort of follow instructions of how its personality is dictated. And that we definitely see that, larger models are much better about that, following instructions, staying in character. So that definitely, like we're focusing on larger models. But one other thing that, I don't think is really getting enough, focus right now, is that, so many of the models have a very dry personality.
Hmm.
And they've largely been trained on single turn conversation, and are trained to be sort of helpful in this sort of like somewhat obsequious, like, assistant, personality. How can I help you? What else do you need? All this sort of thing. And like, no one talks like this, right?
Right.
And so, we're trying to figure out, like, how do you imbue these models not just with IQ but EQ? And so, like, how do you make them have a bit like of personality, and ability to, uh, just like, say something kind of engaging and captivating. And like a lot of times when you have no interesting people, they have like an interesting story or interesting joke or something like that. And so how do we imbue some of this sort of thing? And also just have people feel these models feel a little different. These agents feel a little different. That like you don't feel like you're talking to the same model really, just with like with a different name attached to it. So a lot of thoughts. We spent a lot of time figuring out like what's the right way to do this through like fine tuning, through in context learning, and all that sort of thing. I mean, a lot of it, I think you're working against some of what the RLHF process has actually done, on the model because they tried to make them kind of system-like and that sort of thing. But I think that's an ongoing challenge, and we're seeing some models that are being basically put out with data sets that are trying to make them more creative. But I think that's an area where there's still a lot of stuff to happen. But let me just talk a little bit more about the speed thing that there's some great literature on this of terms like human conversation speeds and like we dealt with this in the RTC world all the time where the notion was that if you have video or audio flowing across the internet, it has to get to the other side. The round trip time for a good call is typically considered to be around 200 milliseconds. And those are sort of numbers that were taken from the phone call, and the phone operators, sort of metrics, that came before us. But it turns out this is all sort of predicated on research in human conversation speeds, and that typically when English speakers speak in conversation, that the time between one person finishing their conversation turn and the next user beginning their conversation is actually only about 200 milliseconds. And so you can see how like these same numbers that came into RTC of like what should the right like round trip latency for a call be, because like if people are expecting someone to take their turn and then nothing happens, then like maybe they'll continue their speech or somebody else will overtalk or whatever. And so long story short, and all these stats are all captured in a really interesting book called like How We Talk. It's available on Amazon. But what this all means is that for our purposes of like how we get these models to respond, that like all the processes that have to occur here of any sort of transcription, followed by generation, followed by actually generating enough tokens to then start playing out, and then any sort of text to speech conversion, all need to happen in the like few hundreds of milliseconds window, and that is a pretty tight budget. We spent a lot of time thinking about how to optimize this. What can we do to make some of the stuff faster? But one of the things that we've done is really try to understand like what are we dealing with exactly, and we've made this new site called thefastest.ai, where we basically take all the top models of today and we kind of put them through benchmarks. We run some benchmarking scripts for multiple data centers around the world, so we can see like how performance differs by region. But overall, just come up with this notion of like, okay, who's fastest and actually responding. And long story short, again, we're shooting for this time frame of like a few hundreds of milliseconds. But some models, Claude 3, really interesting model, really strong reasoning capacity, really interesting personality. But it typically takes about a second from the time that you send it a request, the time it starts to send back tokens. So like if you're shooting for a few hundred milliseconds, you've already blown your budget entirely. Same thing with Gemini 1.5. We ran the same sort of thing. Like I'm very excited about Gemini and what powers it'll have, but it's too slow right now for our usage. So anyway, long story short, right now GPT-4, especially GPT-4 deployed on Azure, is actually a pretty interesting trade-off of very strong reasoning performance and pretty good speed. There are certainly models that are much better. Mistral, the folks at Fireworks, folks that together Even the folks at Grok have done some amazing work to get some of these time to first token down into like the 100 millisecond sort of range. And so like you can start hitting a lot of these sort of numbers that we're talking about when you're able to get the LLM to respond and in those sort of time windows. But I think ultimately we just need to get away from the sort of stage that like we have these multiple uh, there's ASR and there, transcription and the LLM and text to speech, all separate stages. They really just want to have a single model that you can feed in speech and get back speech. And by combining all these stages together, just have that be super fast. So anyway, that was a long sort of journey down, like, why we're so focused on speed, but you can understand that, like, if 200 milliseconds is the metric by which humans communicate, then we need the machines to communicate in the same time window in order for it to feel lifelike.
That makes sense, and that's like like an insight on basically HCI, right? Like how to make the user experience, human computer interaction experience more natural. And I guess like that comes from like your background building out WebRTC and stuff in the past. So one like actually like I have a bunch of follow up questions in the answer that you gave, Justin. One very quick thing, like you mentioned about very specifically about Azure GPT compared to like let's say whatever like an OpenAI version of GPT. What's like and like in terms of the benchmarks, what's the difference that you are seeing, like and is this consistent in terms of like whatever like prompt lengths, completion lengths? What's been your experience there?
Yeah, I mean, we probably don't have the time to really get into all the details, but you'll notice that you can see some markedly different stats depending on the size of your prompt.
Yeah.
Certainly the size of your completion, because there's like the time it takes to run a crank of the model, and if you have to crank it many times for many tokens, it can take a long time to produce all those tokens. But there's some models that can be very fast in responding, even with a long prompt, and there's some models that seem to respond very quickly with a short prompt. But then if there's a long prompt, the time to process all those input tokens, clearly there's some sort of bottleneck in the system, and it kind of leads to overall slow performance. And one example is I think Grok has made a lot of sort of waves in terms of like its ability to be very fast in its deployments of Llama 2 and Mistral. But we've actually found that when you give it a lot of input tokens, that performance falls off very quickly. And so like, there must be something in how like they're sharding like the input tokens across these different machines that just takes a fair amount of time.
Got it. Like personally, like the reason I asked that question is because like we tried to benchmark this like quite a few times, and like if you're running like short enough benchmarks, I don't know, running it like for an hour or two, like a few hours of benchmarking, right? The results of benchmarking itself varies quite a bit when you run it like multiple times across different time windows. Basically, I don't know if it's about like how GPT servers stack up, or like like at that time what's the other load that you're seeing. I don't know if
I mean, we've definitely seen like what we sort of call as like GPT weather, right? That like depending on the time of day and all that sort of stuff, you can have like a ton of different variants in the system. And one thing I'll even just say is that on the Azure side, Azure had been great for us for a long time, and in the past month, Azure performance has really tanked.
Mm,
And the Azure team is aware of this. We've been talking with them at length about this. But yeah, I mean, it is something that I think everybody deploying an application needs to think about. Of like, if you're calling an API and there is no SLA around like latency or anything,
right.
as often there is not, then you're a little bit at the mercy of these providers. And so, at least with like, some models, you can get them from a few different providers. And some folks take, the latency more seriously and everything. But it is an interesting, thing of people who really care deeply about latency. Um, may well find themselves like needing to run their own, basic GPUs essentially, or their own model, their own inference endpoints. Um, just because it's very difficult to have a critical piece of your stack that you don't really control like the performance on. And we may find that, there ends up being an offering from some of these big model providers that, they say, hey, we are going to offer SLA or something around latency, but at this point in time, we don't have that.
Makes sense. Makes sense. And in that context, you had mentioned about fastest.ai, right? Like it's a fascinating work that you all are doing there. So given for this kind of variation and GPT weather, as you call it, is an interesting term. How do you ensure the accuracy, reliability of all the benchmarks that you are publishing? What's the best fallback to solving for that problem in some way?
I mean, I think the best fallback is sort of like, measure often, right? And
Hmm.
so like we run from different data centers. We run the benchmarks, on right now is daily, but we could do that more often if needed. We have found that for the most part, um, the numbers when run at the same time tend to be reasonably stable.
Hmm.
We do run a sequence of runs. We take the median, we discard the high and low things, and so we're already doing a little bit of filtering there. Um, but I think that that filtering combined with running at the same time, we do get fairly reproducible results, and we do see the trends emerge of, like I said, when Azure started to regress in its performance, we saw that immediately in our benchmarking. Um, but I'm sure there probably are cases where, like, GPT performance is probably worse during the workday in the US, probably just because of additional demand from ChatGPT Pro and enterprise users and that sort of thing.
Got it. One other thing, from a technical standpoint, that I personally have faced building out these applications, would love to hear your thoughts on this, is whenever we are building agent driven applications, right? If you're using a framework like I don't know, AutoGen, or for that matter any other multi agent conversation framework, right? um, it tends to have like multiple conversations. Like agents tend to have multiple conversations amongst themselves, which end up increasing the latency quite a bit, right? If you try to control that too much, then your quality goes down in some way, right? So that's like one set of problem around the trade-off between latency and quality. And then the other side of trade-off is when you read the papers about how these agents are architected, the memory layer and the personality layer, you have to really account for all of that into building these different characters, like how they remember the past events, maybe the world knowledge, stuff like that, right? But the frameworks don't support that quite a bit, like all of that right now. So would love to hear your thoughts on how you're solving these two problems today, and are you all using any frameworks at all, or are you building all of this from scratch? Love to get some more details in there.
Yeah, I mean, we spent some time building our own framework. We've really had our hands in the weeds, ever since the start of Fixie, of like, what does it take to orchestrate models? And so we have a fair amount of things around, how we can control what goes to the prompt and history and memory and these sorts of things. And we had our own sort of orchestration layer we called AIJSX, which was kind of a way to express prompts in like the syntax familiar to React developers, which made it very easy to do templating and that sort of thing. Um, and our internal tools are based around that. But I think we've kind of also come to the understanding that it can be very difficult. To build like a platform or orchestration layer if you don't know the exact use cases.
Hmm.
And so I think some of the frameworks have suffer from this, that if you're doing something that lines up with what the framework was designed for, it's like, oh, you want to make a question answering chatbot. Okay, yeah, there's probably a framework can do a pretty good job on this. But if you want to do something where you're trying to give, long form conversations, like ability to sort of remember facts, the ability to like, have experiences, there's probably nothing that's exactly right out there for that. And we found ourselves having to build our own tools, or extend our own internal tools to accommodate these sorts of scenarios. Um, Generally, I think that, until the applications or the niches become a little more well identified. Like a lot of these frameworks are really great to get started, but then people find themselves having to sort of eject in that sort of parlance, to get underneath and be able to kind of run their own code and make their own customizations. And I think that people who are pretty serious will invariably find themselves doing this.
Got it. Besides the internal tech stack that you all have developed here, any other frameworks or any other public tooling that you all have used that you really recommend for people to check out?
I mean, so I've been pretty impressed. We've been using like Mosaic ML for our training of our own models, and I think like that's clearly solving a problem that like many people have of like coordinating like GPU clusters, training across many machines, like moving data in very quickly, evaluation, taking something you train and being able to inference it, and so. That's I think a really good example of some technology that I think that is kind of meeting um, sort of application developers needs where they're at. And I think one of the reasons that I think Mosaic was like this quick acquisition is that that the problem that they were solving is a problem that many people were having, and like that the value they created accordingly is quite nice.
Makes sense. Yeah. Thank you so much for sharing that. And maybe one other question around kind of staying up to date. Like what's with AI moving, generative AI moving so fast. What's your best go to places to stay up to date with what all is happening?
Oh man,
Are you
yeah, that's yeah. I mean, I read a ton of stuff. I think it's hard to say exactly what the best resource is. Like, yeah, I think there's a number of nice newsletters of just finding out like what's new and what's coming out. But I think tech Twitter has almost invariably been my the thing that my eyes have been opened by, of just like
Yeah.
following some of the people in the industry who are really good at kind of like distilling their knowledge and everything. And I feel like I've learned so much from just Andre Carpathy and like, folks like that, who, it's like, oh, I've never had certain anybody explain it quite like that before. Now it all makes sense. So anyway, I find myself, just kind of reading up about like, what, like, how should I be thinking about this? Like the details are often very easy to come across, but like the why and like, like what are we missing? Like, what are the other things? And just can these models really generalize? Well, currently the answer is no. Like
Right.
they're still largely interpolating the curve fitting, but can that change? Like well, we'll see. It'll be interesting to see like how much reasoning whatever are capable is possible in the next generation of models.
Makes sense. Amazing. Thank you so much, Justin. Really appreciate you taking this time. Any last thoughts that you would like to share with our listeners? Anything that we haven't covered that you think would be worth sharing with everyone?
I mean, so I think that one of the things I think is very exciting, and like I went to the AI Engineer Summit, last year, which was a really valuable sort of event that was put together, and some of the folks from OpenAI, did this little demo where they said like, 2023 was like the year of like the chatbot, and 2024 will be the year of multimodal. And I thought that was quite interesting framing, because it really does feel that like a lot of the pieces are sort of falling into place, and that like that's kind of our focus at Fixie. Like we're really focused on multimodal, and what does it mean if you can have like an AI that can speak and hear and understand. But I think that this is really going to be like Sora. I think gives us a taste of kind of the future that I think that awaits us, of like these models that can be able to sort of fully perceive and then communicate back with like generating like bespoke video, like not yet in real time, but probably not too distant future, and just going to be like some incredible experiences that are created. So like overall, like you know uh, the, a lot of, like most of these sort of things, whether it's ChatGPT voice or whatever, run over WebRTC. These multimodal applications are running over WebRTC, and so it's really interesting to see WebRTC have this second act in this new
Sure.
multimodal AI world. And so like it's very edifying to see that. So anyway, I'm very excited about this whole AI journey. Like I know you're on the AI journey too, and it's just like it's a really cool place to be. It's like we're having a lot of fun.
For sure. Like I would not want to live in any other world right now. It's amazing. Yeah. Thank you so much, Justin, for taking the time. Really appreciate this.
Great talk.